some of the basics we did last semester. You good? Yeah. Again, this is week 1, and everything is on YouTube. And we pay attention. So basic electricity, all this information should be revision, it's not new. What is energy? Energy is force. Energy can be power. Energy transformed from one form to another. What is electricity? Is a form of energy. Energy can be heat, can be mechanical, and for our purposes here, energy is electricity. This is an energy that moves electrons from the atom, from one atom to another, and some elements, metallics, usually they have free electrons, so some energy can push that electrons further through a wire. So we realized, at some point we realized that there is energy going through metal, and electrical energy is coupled with magnetism. We saw that video and we saw how it was very interesting, how they were able to couple magnetism and electricity and use this energy for our use. So with that electricity we can make light, and we can also do mechanical movement and move motors, solenoid, and with that we came with a lot of control, and we came to be able to have all the things we have around us now: computers, lights, heat, movement. So electrical energy was very, very essential to us. And to be able to use and deploy electricity, we need an electrical circuit. Circuit is like something that's closed, a loop, a loop, and that is very essential. And we talked about what's called short circuit. And we said short circuit means there is no circuit anymore. Or maybe there's a path, but not a complete path. An open circuit is when this switch is open, the circuit is not complete. So keep that in mind. Listen. Keep that in mind when you have troubleshooting. If there is no circuit, there is no power. You might go and look at the supply, the power, the hot line, and you find power, but maybe the neutral is disconnected, and you will trace it and you don't find a right path. So a lot of times you spend a lot of effort and energy trying to find the error, and it's just the neutral is disconnected or have not a very sound connection. There's a comparison between electrical circuit and water circuit. So in a house you have a water circuit. The water comes into your house, it has to go through the pipes, it does some work. The work is symbolized by the faucets or the shower or the tank, and water has energy. The energy in the water is the movement, the pressure. So the municipality will send water with certain pressure, and that pressure does some work in your house. If there is no pressure, the water will not flow. Also, the water has to go somewhere. So there's a circle where the water goes to the sewer, and that completes the circle. And we talk about types of circuits. We have series circuit, series, and parallel. In series, there is how many paths? One path. What do we use a series circuit for? Safety and control. In parallel, it's basically how we connect loads. If the loads do not connect in parallel, they will have a lot of pressure, and that will be very difficult.
They can't quit.
We talked about our friend Ohm's law, and Ohm's law is very, very important for us, and you'll see how it will be used. We already used that a lot, but Ohm's law is with you wherever you go. And in the top we have the voltage, which is also called electrical potential or electrical force. Current is the flow. So if we were to compare electrical circuit with water flow, the water flow is the current, the potential is the pressure, and the resistance is the outlets, how big the pipe is. Small pipe is high resistance, big pipe resistance. Same thing with wires. Smaller wire, high resistance. Bigger wire, low resistance. So it's very comparable. And how do we calculate the resistance? Divide voltage by current. The same here. How do we calculate the current? Divide voltage by resistance. And if we want to calculate the voltage, you multiply resistance times current. Power calculation, we talked about that as well. And we said, what is power? If we talk about energy as a source of power, what is power? Power is energy over time. So power implies time. If there is no time, there is no power, it's just energy, a reservoir. And we said the comparison between a Ferrari and a Civic. Whatever you want. I love Civics. I have one outside.
Oh, you got the new
Oh, you got it?
Yeah.
Got a new little jump?
That was
Not new.
It's a new used.
How was it challenge?
It's new to me.
Wait, how was it a challenge?
Huh?
How was it a challenge?
Well, it was very cheap, so I fixed some stuff in it.
Damn.
How much was it?
Where'd you put all those menus?
Very cheap. Very cheap price.
How many miles?
Almost 200. Yeah. But I love it because it's really easy to fix. Anyways.
Where'd you put all those menus?
Huh?
Where'd you put all those
Yeah,
menus?
and you can make it into.
I love the side though. Civic and a Ferrari. They use the same energy, right? Maybe Ferrari is an extended, but Ferrari is high octane. Let's get something else. A Mustang. A Mustang, okay? Same gas. 87 octane, that's the energy. But the power depends how fast do you burn the energy. A Civic will give you 30 miles per gallon, a Mustang will give you 15, which means it burns fuel faster. So there's a component of time. So either you have time, and that's how you spend your energy. That's what we use for power. More power, less efficient, means you burn the energy faster, but you get more power out of it. And that is the basis for what we pay for. We always pay for kilowatt hour. So our power will be how much voltage, which is potential, and how much flow is going on. So if this is gas, the current will be how much gas you're spending per second. What is the flow? MPG. So the gas is the same, but the power is either faster or slower. But gas guzzler will take a lot of current, a lot of flow. Gas will be going down. You can see the needle going down. With small cars, like fuel efficient, you will get less. So power is kind of the voltage, is how you spend the voltage over time. Questions? Okay. Adding resistance. We did that a lot. It was interesting. Some people found it challenging, but it's still important. Adding resistances in series. The resistance add up. You add whatever you have. The advantage is again safety. If one fails, the circuit is open and it fails. It is easy to control because again, if you want to cut off the circuit, you cut off one of the resistances. Yeah.
I thought you did one over.
That's
That's parallel.
Yeah. Disadvantages, there is no backup and you have high load. If you put two resistances in front of each other, if one of them go out, the other one will go out. We give the example of Christmas lights. And again, they will add up, so the resistance will be very high, which means if the resistance is high, you consume a lot of power. So this is circuit in series. Again, please try to remember that loads we connect in parallel. Safety switches, fuses in series. Dial. Circuit in parallel. This is how we do the total. And you can do the whole flip, divide, add, flip again. We did that a lot. Advantages, you have redundancy. before letting go out, the other one will still work. And again, what is the total resistance equals to? What is it supposed to be?
Less than the lowest one, right?
Huh? Yeah.
Less than the lowest one.
Yes. The resistance will be smaller than the smallest one in that parallel circuit.
So what happens if it's not?
Huh? You need the math wrong. Yeah. So, any questions about that? We need to remember that because you'll do some wiring, and we have to remember if things are wired in parallel or series. It gets confusing with the actual wiring because you're gonna have plenty of wires coming out. Fuses and circuit breakers. For safety, we talked about circuit breakers in your house, and if you go to the control panels, what is the amperage on circuit breakers? Usually? Huh? Sorry? What is the, if we have a circuit breaker, and we have those little switches on it, what does it say on it? 15. 15 is the average breaker size in a house, except if it's an oven, you must see 20. The garage usually have 20, because you're gonna have a lot of power tools. And what would happen if you exceed that 50? Huh? 50?
Yeah.
Okay.
40 or 50, it'll be a 2 block.
That is a huge, that's 220 though, probably. That's 220, what do they do?
There's just a lot of
I could just do it.
Not my problem. I hear Bill.
Okay. Reasons we have 15 amps is to prevent short circuits, and in case we have an excess in amperage draw, it will trip. How would we have excess in amperage draw? So let's discuss first the short circuit.
Using the microwave and 3 air dryer at the same time.
Yeah. For example, you have a short circuit, something wasn't connected correctly, the thing will trip. The breaker will trip. How would you have excess amperage?
Could it be different things require more, like in AC, you turn on
Way too many stuff in the
You put more appliances in the same circuit, and you turn them all at the same time, one of them will trip. Blow dryer at the same time as toaster. AC. How would you have both at the same time? But for an AC, for example, if we have an AC, it has its own circuit breaker, and the circuit breaker trips. What happens? You see it again? You have an air conditioner, it has its own circuit breaker. You turn on the AC, and the circuit breaker trips. What do you think happens?
There's not enough. Which one?
Should top on it. The AC one should top first.
Why? Why?
Because it has its own individual.
Yeah, but why did it trip? Well, what could have happened in there?
The motor shot.
The motor is stuck. The motor is stuck, is overheated, it's trying to turn on, something wrong with it, it will trip the circuit breaker. So don't try to go back again. Reset it and try again. Probably something wrong with the motor. You gotta go and check the motor. Did anybody get that? Everybody got that? Same thing with an oil burner. If the motor is stuck, we have something called locked rotor amperage. And if it's drawing too much because it's stuck or struggling or there's too much friction, it will draw too much amperage and it will trip the circuit breaker for safety. If there is no circuit breaker, what will happen?
Keep going, keep
It will
going.
it will overheat, you're gonna have fire, or you're gonna ruin the circuit. Ground system, we talked about ground, fault, circuit interrupter, GFCI. So ground means a wire went where it's not supposed to be. Touch the casing, it fell off, that's when you have ground. So ground is very important to have, especially in big equipment. We have also thermal switches. Where did we see that? On motors. We saw thing popped, had a motor here. If it overheats, it has a sensor, and that sensor will pop, whether mechanical or electronic. If you have too much heat, it will disengage the circuit. Again, it's a means to protect your circuit. Your phone has it. If you leave your phone on the dashboard during the summertime, it will tell you the phone is overheated and it's not going to work anymore. So if the phone overheats, it has a sensor in it that will tell it to shut off to protect the circuit and protect the phone. So safety, circuit breakers, fuses. Electromagnetism. We did talk about it. We have the video that's an hour long. I put it again in case you want to rewatch it. And the purpose of that video is to show you the progression and development of electrical circuits along with magnetism. Why do we need to know about magnetism? Because it's the basis for making a motor. It's the basis of making things move using electricity. You can move a compass, you can move a solenoid, you can move a motor, and you can make a magnet out of current. So these things we have to just think about and know there is a relationship between moving objects and electricity. Okay. I think I will stop here. And it's the first class. Next class we'll keep doing some review and we'll transition into an oral book. For now, I want you please to try to get the book by next class at least, so we can review that. Yeah.
That's the one that's online, right? So
Huh?